welcome back to school. So today I'm going to be talking about a Cookstove evaluation of a Cookstove intervention in rural India. So before I go into the details of the project, I'd like to give you a brief background on why a Cookstove intervention is important, as well as why evaluating this intervention is also important. And then I'll go into the preliminary results of the study. So there are over 2.5 billion people in the world that use biomass for cooking. By biomass, I mean wood fuels, agriculture crop residues, and cow dung. And much of this population is located in developing parts of the world. As you can see from the map here, it's in most of the population is in sub-Saharan Africa and in Asia, and some also in Latin America. And of that 2.5 billion people that are using biomass, a third of this population is in India. And much of this fuel is burned inefficiently in traditional and open fires. As you can see from the pictures here, people are using 3-stone fires or just basic metal frames, or just at the bottom, at the bottom here, mud walls to burn these biomass. And so it produces a lot of smoke, which has implications for health and climate. And also you can see a commonality amongst these pictures is that it's mostly done by women who are caring for their young children. And so the exposed population to these smoke are mostly women and young children, which has implications for health. There's been strong evidence showing that exposure to household air pollution is associated with several adverse health outcomes, including chronic obstructive pulmonary disease in women, lower respiratory infection in children, and also emerging evidence showing cardiovascular diseases. And in countries such as in China, where coal is heavily used, there's also been association with lung cancer. So all of these health outcomes contributes to an estimated 3.5 million premature deaths per year from exposure to this household air pollution. And in India itself, it's been estimated that 500,000 premature deaths occur because of this exposure to smoke from inefficient combustion of biomass. And this is showing you the top risk factors for morbidity, so illnesses in developing countries. And you will see that without paying too much attention to details, household air pollution ranks the 4th highest risk factor for disease burden in developing countries. And so it's pretty high up there. And also I highlight high blood pressure because there is emerging evidence showing association with cardiovascular disease, and high blood pressure is a risk factor for cardiovascular disease. So these are pretty much very important health issues in developing countries. And in addition to health, there are also climate relevant emissions that are included in the smoke. Typical greenhouse gases such as carbon dioxide, methane, and nitrous oxide are emitted from this inefficient combustion of biomass. And more recently, what we're finding is that black carbon, which is a dark component of particle pollution or particulate matter, is also emitted from this smoke. And it's estimated that 70% of black carbon emissions in Africa and Asia come from inefficient combustion of biomass. So, and the thing about BC, black carbon BC, is that because of its dark nature, dark color, that it easily absorbs heat from the sun. And also when this black carbon gets transported into the atmosphere and it settles down onto snow and glacier, it speeds up melting. And so because of this direct and indirect effect on climate, it's now rated as the 2nd most important greenhouse gas after CO2. So, and in addition to climate, so we've got health climate, there are also livelihood impacts because inefficient stoves consume more fuel wood. So it's a time, energy, and financial burden on families that have to go out and collect fuel wood, and also it takes longer to cook. And in these many parts of the world, it's the women and young children who are involved in collecting fuel wood. So it's a huge energy burden on these families. And in India, there was a national survey done on how rural women spent their time, their time-use activity, and what they found was that rural women spend about 4 to 5 hours a day collecting fuel wood and cooking, and another 6 hours on other household activities such as childcare, fetching water, and preparation of food, and only 2 hours on income-earning activity. So the argument is that for cook-stove intervention is that if you are able to provide stoves that consume less fuel wood and also takes less time to cook, then you can allow women to dedicate more time to income-earning generating activities and improve their livelihoods. And so because of all these impacts and potential for improving both from a health, development, and climate perspective, there's been a renewed momentum for intervention. As an example, at the international level, there's been a global alliance for clean cook stoves that was recently created in 2010 under the leadership of the UN Foundation. And they have quite an ambitious goal of distributing 100 million stoves by 2020. And then at the national level, there are also efforts such as the National Biomass Cookstove Initiative that plans to distribute 100 million improved stoves in the next decade. In addition to these international and national efforts, there are also increasing number of climate finance interventions, such as the CDM, Clean Development Mechanism, which is a market mechanism that was created under the UN Framework Convention on Climate Change. And it allows investors in developed countries to invest in projects that reduce carbon emissions. And so clean cook stove interventions qualify under this market mechanisms. And so there's an increasing number of projects that are entering, cook stove intervention projects that are entering this program. And so the problem with that is it's great, there's an increased effort and interest and effort to improve the situation, but the problem with that is we don't have a definition or a standard for what is an improved stove. This is just an example of different technologies out there that's showing you, for example, rocket stoves are the next improved stove over the open fire that is used. And it's basically, provides an enclosed combustion chamber. And then going up to basic brick stoves that have chimneys so that takes the smoke out inside the house to outside, to other stoves that are more technologically advanced in terms of they have fans and things like that, that improves combustion efficiency, to stoves that use gas and electricity, so uses a different fuel. And so, but the problem with that is that as you go up the ladder to increase efficiency, there are costs associated with it. And so because of that, there are affordability issues as well as acceptability issues by the users. If they may not be able to cook their certain dishes with certain type of fuel or technologies. And so there are a couple of issues with this. And also to note that most of the interventions that occur are around this area because they can be locally produced, so they are relatively cheaper, and also fuel sources such as wood fuel are more locally available as opposed to trying to bring in natural gas or grid system electricity into these rural remote regions. And so most of the interventions occur around here. And so within this context, an Indian non-governmental organization called Samuha is planning to distribute improved cook stoves. And they plan to do this in about 110 villages. And they are the first CDM-approved stove intervention project in India. And they plan to reduce over 46,000 tons of CO2 equivalent per year over a 10-year period from this intervention. So basically going from this type of basic mud, three-wall mud stoves to a more efficient contained combustion chamber stoves. And so a little bit more about this intervention. The stove that they're planning to distribute, it's called Chulika, and is, as I explained a little bit earlier, it's based on a rocket stove design, so it's one step up from an open fire stove, open fires. And that basically it's just, they provide, this combustion chamber is insulated, so it increases the combustion efficiency from increased heat. And so in the market, this cost is $35, but villagers pay $5 to participate in the CDM program. And according to measurements that are done in the laboratory, it has 3 times the efficiency of a traditional stove, and also saves wood, 46% wood savings compared to traditional stoves. And this is the picture of the NGO staff that's doing an education orientation program in the village about the stoves. You can see the stoves at the back here, the chulikas, and they're introducing it to the villagers. And the location where this intervention is happening is in Karnataka state, which is in southern India. And this is in Karnataka. Bangalore is the capital, state capital. And then, so the intervention is happening in the northern part of the state, where this region is mostly rural and agricultural based economy. And majority, 89% of homes in this region use biomass for cooking. And within that number, almost all of them cook with open fire traditional stoves, and also 90% of them cook indoor. So there's a high indoor air pollution. And so just to show in a picture, the NGO Samuha is planning to implement this intervention in 110 villages, but prior to going full scale, they are planning this intervention in a pilot village. And so this is where we come in to form a collaborative partnership with another NGO, Bangalore-based NGO, Resource Optimization Initiative, and 3 universities in North America, where together we provided we worked and exchanged technical and field knowledge, and the field team also, the Samuha NGO provided us with the local team staff. And so basically, this is also to emphasize the fact that this is an intervention that's gonna go ahead without us, whether we evaluate this project or not. We're not responsible for the intervention, it's the NGO that's doing the intervention, and we're sort of providing an independent evaluation of the outcomes. And so the study rationale for why we want to do this is because rigorous field evaluations are limited. There's only been a few randomized controlled trials that are conducted, only one in Guatemala and one in India, and they've provided mixed results. In Guatemala, they were successful in reducing indoor air pollutions, and they saw some improved health outcomes. But in India, a large randomized controlled trial was conducted, and there wasn't, they did not see any substantial reductions in air pollution or health outcomes. And also because, as I mentioned earlier, there are different technologies stove technologies out there. We don't know what is really improved or not. So we need to do a field trial, a rigorous field trial to assess that. And so ultimately, we hope to provide an independent evaluation of this intervention so that we can inform policymakers on how to maximize health, climate, and development benefits. And so the research questions that we were interested in was, does moving from a traditional biomass stove to an improved Cookstove, does it reduce indoor air concentrations? Does it improve cardiovascular health and eye symptoms? And also, does it have benefits for livelihood outcomes for the users, as well as other air pollution measurements that are looking at particles and CO and CO2. So for my thesis and for my analysis, I am focusing on these 3 topics, which are indoor air concentrations, particularly looking at particulate matter and black carbon, and the health and the livelihood outcomes. So the methods that are involved in this study is we distributed surveys that collected socioeconomic status, information about households. And to assess the livelihood outcomes, we did surveys of self-reported time use. So we asked the women how much time they spent collecting fuel wood, cooking, cutting wood, and so forth. And also we did an indoor and outdoor air pollution measurements for PM 2.5, particulate matter, small particles, and black carbon. So these are the pictures. You can see our field team doing the surveys in the villages. And these are the air pollution measurements that are conducted in the kitchen while the over 24-hour period, but also it's in the breathing zone of the women. And then we also put an outdoor air monitor here. This is a weather station, and this is a tree branch that's with our funnel that's collecting air measurements. And then we also took blood pressure measurements of non-pregnant women over the age of 25. And we took anthropometric measurements, salt weighing, and medical conditions, so confounders that could potentially influence blood pressure outcomes. And also we weighed fuel wood before and after a 24-hour period. Again, these are pictures of the blood pressure measurements being taken and fuel wood weighing. So this is a bird's eye view of the village where we conducted this trial. So the outdoor air monitor was somewhere in the middle to get the village air pollution concentrations. And we also put up an air monitor about 2 kilometers upwind of the village to get a background concentrations. So the results are, so there's a lot of information here, but you don't need to go into you don't need to read all the details. It's just to show that we conducted a randomized controlled trial. So starting with 300 households in the villages, 200 were eligible to participate in the CDM intervention program, and of which 187 consented to be in our study. So we randomly assigned them into a control and intervention group. And then we did baseline measurements, which I call season 1, in the fall of 2011. And after the baseline measurements were taken, the chulikas were introduced. The intervention was introduced into the intervention arm. And then second, in season 2, we collected the follow-up measurements, which was in the spring of 2012. And so again, don't get too drawn into the details. This is just to show you that all the socioeconomic status information and other relevant information that we collected on the households, and also showing you a comparison between a control and intervention group. And so when we did an analysis, it shows that the p-values were not significant, meaning randomization was successful and that the socioeconomic status and other characteristics between the control and intervention group were similar. And similarly for female participants, there was very much similarity between control and intervention group, except there was a marginal significance in BMI, so we'll have to control for that because it can confound with blood pressure measurements. And so in terms of what we first found was that there were issues with stove adoption. So not everybody who the NGO distributed the stoves to adopted the intervention. So you'll see that only 60% of the intervention households took on the intervention as intended, meaning two stoves. And a third of them were using it in combination with the traditional stoves and the new stoves. And so you'll see in the pictures here, this is the household that's using as the intervention intended, because they normally have 2 fires at home. So then they are using the 2 chulikas. And in this household, you'll see that the chulikas have been moved to the back, and they're using a mixture of the chulika with the open fire, three-stone open fire. So this falls into the mixed stove category. And then in this case, they've even, similarly using a mixture of the chulikas and the traditional stove. So one of the main reasons for why not all households adopted the 2 chulikas is because many households said that they had difficulty making their rotis, which is their bread, and because the fire was much more intense and concentrated in the middle, it burned their rotis, the center of the rotis. And so they would use the traditional stove to make the rotis and then other dishes on the chulicas. And also some other smaller percentages of people experiencing poor quality of the stoves, and the fact that they need to cut wood into smaller pieces took more time, and also the fact that the food tastes different in a new stove. And so those were some of the reasons for why they did not use the intervention. So in terms of air pollutants, this is to help you visualize the type of air pollution levels that we found in this community. And if you just concentrate on the right side here, this is a filter that was sampled upwind of the village. And so it's relatively, it's white, and so there's not much contaminants on it. But then you come to the village center and you see a little darker shade, and it's 3 times higher than the upwind of the village. And then you come indoor and the medium concentrations jump to 228 microgram per cubic meter of air. And you see a darker color filter, and then you get to the 90th percentile concentrations where it can be as high as 1,000 microgram per cubic meter of air, and it's completely dark black. And so this graph is a comparison showing you PM 2.5 concentrations, particularly matter concentrations, by indoor, village, and upwind of the village. And you'll see that the concentrations indoor are substantially higher than what's found upwind of the village and in the center of the village. And also you'll notice that this red line is the WHO air quality standard for PM 2.5, which is 25. So the indoor concentrations are much, much higher than what is recommended by the WHO. And now I'll show you the graph on what is the change in indoor air pollutant concentrations in these different households. And this is a graph showing you, particularly matter, a change in PM 2.5 concentrations by the different types of households, which is control and intervention group. And so you'll see that the median line is above 0, which means that over 50% of households saw an increase in the second season in PM 2.5 concentrations. Although there was a trend in a lower increase in the intervention, they were not statistically significant. And now looking at the second pollutant, which is black carbon, the change in also in black carbon concentrations by the control and intervention group, they both saw an increase in the second season, but they were not significantly different. So because we saw households that were using a mixture of the improved stoves and the traditional stoves, I wanted to see whether those households were sort of meddling in with this, our inability to see the difference. And so in the next graph, I did the analysis by the households that use the different stove. So you'll see that here it's divided into the control homes, the original control homes that continue to use the traditional stoves, homes that only use the 2 chulicas, the improved stoves, and then the mixed stoves, so homes that were using a mixture of the chulicas and the open fire. And what I found was that, again, there is no statistical significant difference between these 3 groups. And similarly for black carbon, we did not see a significant difference between these 3 groups. So to put these 2 pollutants together to simplify this analysis and see what's going on, I have done this analysis where I took the ratio of black carbon and PM 2.5 concentration because, in essence, black carbon is a component of particle pollution. And so in this ratio here, what this shows is that, so let's looking at the control group. This is season 1 and season 2. There was an increase, as we all know, but there was no significant difference in the increase in the ratio. But if you look at the 2 other groups of 2 chulicas and mixed stove homes, season 2 in both of these groups were significantly higher. So meaning that the chulicas were producing a higher proportion of black carbon, which is not good from a climate perspective or health. And so in terms of health outcomes, what we saw was that if you look at the left side, looking at systolic blood pressure, there is no significant difference, again, between control and intervention group, which is not surprising because we're not seeing a big change in air pollution concentrations. And for diastolic blood pressure, similar. There's no significant difference. And for eye symptoms, it's interesting because this is the percentage of women who report eye health symptoms. And what we saw was that in all three types of homes, they report a significant decrease in eye health symptoms, but it was only significant in homes that are using the two chulikas. So there are two reasons for this. One could be that because this data is based on a self-report, that it could be biased because in a way, households are not blinded to the intervention. They have the stove right there, so they may be biased in reporting, or that perhaps there is a change in chemical constituents of the air pollution that reduces eye health symptoms. So we don't know this, but it's interesting to note that the self-reported health outcomes show a significant reduction in the homes that are using the improved stoves. And in terms of fuel wood use and time use, what I also found was that in all three groups that are controlled two chulikas and the mixed stove use homes, all of them experience a reduction because the medians are all below 0 in the second season, but they were not statistically significant amongst the three groups. And in terms of time use, it was interesting and really challenging to analyze this. First of all, just to say that, again, the self-reported time use, there's no significant difference between control and intervention groups for fuel wood collection, wood cutting, or cooking. And also, what I noticed was that there was a huge variation in time reported. What I found out later was that, one, there were challenges with self-reported time use because in rural parts of in this village, time doesn't go by clock time, and so we were asking them, how long do you spend a day collecting fuel wood, and reporting 20 minutes, 30 minutes. That's really difficult, and also that some of the fuel wood collection is being done together as they went out to do farm work, and so they were reporting the farm work in addition to the fuel wood collection, and so that led to a huge variation in time reporting. So last summer, I was in the field, and so I accompanied a few of these women to find out what is going on in terms of why is there a huge variation in time reported. And this is when I found out that I got permission to accompany this woman, and I found out that she was doing her farm work, and then at the end of the day, she took a 20-minute detour to the nearby farmland to collect the fuel wood. And this is another woman that did a separate trip on her own to the government land to collect fuel wood. So in this case, the self-reporting time is a little more accurate in terms of because it's a sole separate trip just for fuel wood collection. And also, I found out that there were men who were doing overnight trips to run other errands and also come back with a cartload of fuel wood from further away places. And so it was really a challenge to collect self-reported time use data to analyze for the livelihood impacts. So in summary, there is a low and poor adoption of the intervention in the pilot and it's interesting because this was an intervention in a pilot village, and so the NGO team was quite intense in their monitoring of the stove use. They would go in once a day, every day with our sampling team to go into people's houses and troubleshoot any issues and make sure people were using the stoves. But when the CDM program rolls out to 110 villages, the CDM requires a once-a-week monitoring. So it's going to be less intense, and so compliance may be even a more major issue. And also, and in this study, what we found was that Chulika stoves were not effective in reducing PM particle pollution, black carbon, blood pressure, or fuel wood use and time use. And also what we found was that there was a significant increase in the ratio of black carbon to PM 2.5 in stoves, in homes that are using the improved stoves. Did I somewhere else? So what does it mean for future climate finance stove interventions? One is that we really need a rigorous field evaluations of these interventions, and also that we may need a much more efficient stove than what is being distributed as part of this climate finance programs to see a substantial reduction in air pollution, and also that we need to incorporate health evidence into these interventions, because at this moment a lot of these programs are based on how much fuel wood you use, which are based on laboratory measurements as opposed to field measurements, and also there is very little consideration of the health outcomes. So my plan for 2014 is I will be going back to the same field site, and I hope to do some more knowledge translation to the community partners, so present the results of this study to them. And also I'd like to probe further on time use activities because of the problems we had with the earlier data on self-reported. So this time I'd like to go and do actually an objective time use measurements. So instead of just self-reported. And also, I like to do some interviews with the women to find out if there is time saving in these households, what do they do with that extra time? Do they engage it in income generation activities, or is it used for leisure, more sleeping time, or things like that? And so I'll be using a mixed methods approach, quantitative methods that includes a GPS to track women as they go and collect their fuel wood, eye buttons that can be attached to stoves that measure how long cooking takes, and also participant observation, as well as qualitative methods doing focus group discussions and interviews with the users, women users, and men as well. So this is just a little test that I tried out when I was there 2 summers ago, where I accompanied the women with my GPS to see where they went and how long they spent. So I hope to be, from this study in 2014, I hope to collect more data such as this to probe further on the livelihood and time use aspects. So these are the collaborators at Samuha, this NGO, local NGO that we collaborated with. So NS and Pradeep, and also at the University of Minnesota, Julian, Jill, Bruce, and Ram. And at UBC, you may know Connor. He was a PhD graduate from IRIS, and also Andy Grishop, who did a postdoc here and at the LU. And they were both instrumental also in the project development and implementation. And also the staff in another local NGO, Grishma Karthik, they're great project managers who made sure the project ran smoothly on the ground. And also, I like to give my thanks to the field team and the villagers who opened their door to us. And also my thesis committee members, Doctors Michael Brower, Julian Marshall, and Hisham Zarifi. And also the funding came mostly from University of Minnesota, where the PI is based. And I also got funding from the Bridge program for my trips. So I think that's it, yeah. So if you have any questions. Yes. Yeah, there's there are several studies that try to analyze what sort of characteristics of households and individuals that increase their adoption, and what people find is that households that have the head of the household has a higher education or income are more likely to increase adoption, and so as well as there are also that's individual characteristics, and also studies showing that for the women, perhaps they're concerned more about sort of their the smell of the clothes that the smoke makes, or the cleanliness of the pot in the households because of the smoke. And so if you're able to emphasize those benefits that matter to the users, then there's potential for increased adoption, as opposed to what I had noticed when they were doing the orientation, introducing this stove to the village. We keep hearing the word bhumika, bhumika, and we're like, what is that? So they were talking a lot about earth warming, global warming. And so they emphasize a lot on that because this is a CDM project. But to the villagers, this may not mean much. And so perhaps there are certain characteristics that need to be benefits that matter. And also, one of the reasons why we included health symptoms is, eye health symptoms is because the villagers were actually concerned about their eye health as opposed to other outcomes. And so that's why we had included that in our study, to see if there is a difference. And so things that matter to the public, to the users, are probably better. And also there are economic incentives that I think there are studies, and probably Hisham can speak more to that. So incentives, doing sort of, if you provide a financial incentive, are they more likely to subsidize the cost of the stoves? Are they more likely to use it, or as opposed to providing free stoves, as opposed to having them purchase it? So there's different mixed results of that also. Not just in, as you say, not just in stove intervention, but things with mosquito nets and things like that. Like, how do people adopt depending on different economic incentives? Milind? Yeah, right. Yeah, I think, well, this is I think an example of, the CDM, right? This is what's approved by the CDM. And yeah, it's, but, yeah, sure. Yeah, there are two aspects of that. Just from talking, yeah. Angela? Yeah. Right. Regulation would be just with the wood fuel. So they're just So it's a slow regulation. If it's 2, they'll just pull out the wood. Yeah. Mm-hmm. Most of the households use woody fuel, so we didn't weigh other crop residues or cow dung because of that. They might have mixed in stuff. Right. Yeah. There were some measurements done on the moisture content of the stove, and so Andy Grishop at the North Carolina State University, he will be looking at because he's looking at the emission data. So he'll be looking at the emission and then using that moisture data to see if there's an influence on that, because it is in different seasons. So that may be the reason why we see an increase in the everybody increase in the second season, because of maybe perhaps an increased moisture, or perhaps because it's winter and so they're burning more for heating and stuff. Yeah, right, right, yeah. Paige? Mm-hmm. Yeah, I believe the intervention is going ahead. I think Hisham was in the field recently. Yeah, but I guess one of the great things about this model is because it's implemented by a local NGO, and the manufacturer is also based in Bangalore, so not too far from the field site, that they have incorporated even from this pilot village when they were having issues with the rotis burning and some of the materials falling apart. They fed that information back to the manufacturer, and they try to improve it. And in fact, they only after they found out that the stoves were falling apart, they started running tests in the factories where they were burning, cooking for a long. They did not do this before, but they were cooking it for long, like several hours a day, because they were surprised that the material of the stove didn't withstand use in the field. And so so that's what's great about it, is that they are improving and the model based on what they find in the field. In fact, during our study, they increased the thermal efficiency from 30%, which was earlier, what we were studying was 30%, to 40%. But we asked them not to introduce that into the pilot village because we didn't want to have more variables to deal with. So yes, I believe, I don't know, at this moment, I'll find out when I go back what else they have done, improvements they have done to the stove to increase efficiency. And your first question about laboratory-based field measurements, it's well known. There are studies showing that stoves that are, have efficiency of, 80%, 90% will drop drastically in the field. So really, you can't use laboratory-based measurements to estimate what will actually happen in the field because of so many variables, such as differences in wood fuel, moisture and behavior, type of food cooked, and so forth. And so really field evaluations are what need to be done. Tom?
Just to follow up on Olson's question, do you infer or calculate or estimate the actual efficiency? Do you have the lab-based efficiency to show that you have some of the inputs you need to calculate fuel efficiency, but you see that maybe you did calculate this didn't, the subject follows the problem and or it costs about and they
terms of the field emission efficiency, that is what Andy Grishop is doing. So because we were measuring indoor concentrations, which means just in the breathing zone, what the people were exposed to, as opposed to he had an instrument that was directly above the fire. And so that would allow us to see what are the efficiency and compare that with the lab-based. And for your second question, I don't really know the pipeline of how it goes up, but definitely Samuha is still our close collaborator, and I'll be going back there and working with them to probe more additional issues. And so I think they are actually quite a dynamic NGO, and so I think they are very much open to it. And as Hisham says, and I also, when I had gone back earlier, when I also just talked to a few of the women, and they all said, oh yeah, there is an improvement in fuel. They have to go out and collect less fuel wood now because of the chulikas and so forth. And so I think, and also the changes that have been, improvements that have been made to the stove. So there is a willingness to improve and change, but it's also a cost issue. Like, yes, we know that more efficient stoves are needed, but how will they be financed? So this is, and also the fact that prices for carbon credits are also not doing so good. And so, the knowledge is one, but also the practicality of whether we can support that is also the other problem. I don't know if that answers your question. I don't know if there's a new person, Ganella, and then I'll come back to you.
Yeah, I was curious about if you were going to go back and ask about how we try to understand better how the women are using their time. How is that related to your research question?
The livelihood aspects. Because the earlier data that we collected was on self-reported, and I was not able to use that data well because of wide variations in time and issues with reporting a clock time increments. And so I'm hoping to do an objective measurements. So one is to doing a GPS, so I'll know how long they spent not just going to the farm, but also doing fuel wood collection, and also participant observation of how perhaps their cooking order or variation changes in a household, and whether it actually saves time or not. So doing an objective measurement as opposed to a self-reported subjective measurement.
I'm curious because there was a study, I think it was from Kenya many years ago now, a similar one, and where the husbands were very worried that the women would have more time on the hands for collecting water in that case, because then they would be cheating on them. So what other aspects, what's the risk of having a GPS on the women and totally tracking what they're doing? And have you at all discussed sort of the social implications of reporting your time,
Yeah.
controlling your time and so on? Any comment on that?
Yeah, that was one of the things that I have to consider in the consent and ethics application. So we will definitely be getting a consent for that, and also notifying them the type of data that we'll be collecting. So, but yeah, I don't know. I'm aware of that issue. Yeah, I guess if there are concerns that they don't want that information to be collected, we won't be forcing it on. I think I have a sample of 80 women, and so in this 3-in-a-household village, it should be enough to get samples from women who consent. Do you have any other recommendations?
Not direct, and it feels dangerous to GPS them, but I don't know why. And I also was thinking about you have already interviewed them, and they say that they have more time now, and it takes less time to collect them, it lasts longer. I don't know if knowing exactly how much time they use is useful rather than knowing what they would like to do with their time.
Right. Right. Yes, I will be doing that too. I'll be doing interviews with the women to see what they actually do with the save time. Because one woman that I talked to said she just slept more. So she rested more at home. So the thing with that is that a lot of the cost-benefit analysis that are done, they just directly sort of, okay, an hour of time saved per week, and they translate that into a rural wage amount, and they say this, and it goes into the benefits, financial benefits. But actually, that may not be what's happening, that it's used not for income generation activities, but for leisure, which isn't a bad thing, which is, it's probably valued quite highly based on the schedule of these rural women, hours they spend working. So I will be doing qualitative interviews with the women as well. Okay. Yes. I'd like to do it for everyone. This NGO works closely with the manufacturer as well as the villagers, and so I like to be able to do it even down to the participants of the study. But also, I don't want to step on their foot. So the first thing I'll be doing is when I arrive there to talk to the NGO to see what their recommendations are for how we can translate to the participants. But especially because of language barrier and so forth. So I imagine that it's their field team that would be doing the knowledge translation. This NGO is fairly, it's not a sort of it's a Northern Karnataka-based NGO, and so they're very, obviously the relationship is not always, perfect, but they work very closely with the community partners, so they're not an outside NGO that comes in and sort of, so they're very connected with the community. So I'm fairly confident that sort of the recommendations that they give and so forth will be very practical and useful and beneficial for the community. And it's time. Thank you.